Section 4. Data View and Hierarchy. Introduction. Data, as you have learned, can be of different types. The external representation of data is easily understood by humans. However, there is a relationship and some sort of hierarchy with computer data. This will be examined in this study section. Learning outcomes. At the end of this study session, you should be able to 1. Explain different views on data. 2. Discuss logical view of data. 3. Explain different physical view of data. Different views of data. The logical view of data is the way data are perceived by end users or business specialists. This means how data is seen from other users' point of view. We would easily come to terms with an Excel file, a database with the attributes of all the staff in a company, and so many other examples. The physical view of data is the way data are actually organized and structured in any physical storage media. Figure 4.1 depicts the two views: file to record, to feed, to character, to bit. Logical view: file to cluster, to block, byte, bit. Physical view. Logical view of data. Logically, people can easily recognize a character, say letter B, C, X, 1, exclamation mark, and a whole lot more. When these characters are grouped together, they make a feed, not necessarily a word as you would have thought. Remember our teacher that collected data about our pupils. The table is reproduced below with a few additions. The table has 6 fields, namely S/N, surname, first name, middle name, gender, and date of birth. Each field contains a different data about a particular child. However, when we group the fields together, we have a record. That is, a record more or less represents a child. And at the top level, we have a file, which is a group of logically related records. Logical files are treated in the next study section. Physical view of data. The following are the physical view of data: 1. Bit, 2. Byte, 3. Blocks, 4. Physical block, 5. Logical block, 6. Clusters, 7. Files. 1. Bits. Every information or data used by the computer is stored with binary symbols. By binary, we mean having 2 and only 2 possible states, such as on or off, true or false, and 0 or 1. Each single magnetic entity or electronic data on the computer system is called a bit, which is short for binary digits. Binary digits are represented in written communication as zeros and ones. These bits are in the realm of logic, which is a matter of reasoning and not arithmetic calculation. We have seen in earlier modules examples of these bits of data. However, bits are not easily visible to the end user, thus they have no place in the logical view of data. Bytes. When 8 bits are considered together, they are referred to as a byte. A single 8-bit byte is the amount of computer storage typically used to store a single letter of the alphabet or other symbol of human communication. That is, 1 byte is used to store 1 character. The word animal could thus be stored in 6 bytes of computer storage. The byte is so common to computers that disks are referred to in terms of how many millions of bytes can be stored on them. Disks that can hold hundreds or even thousands of millions of bytes are commonplace today. Usually, computer bits are counted in powers of 2, that is 2 raised to power n, where n is greater or equal to 0. The table below shows the common name for some groups of bits/bytes. 3. Blocks. The surface of a disk is divided into sections. This sectioning is not a physical marking on the surface, but rather it is just an idea that the disk is so divided. These sections are called sectors or blocks. The time sector is more common to personal computers. Usually, a block is a collection of 512 bytes. A block is the unit of data transferred between the disk and memory. Records of a file are allocated to disk blocks, usually 512 to 4 KB. The blocks can be physical or logical. 4. Physical block. The actual arrangement of information on the surface of a disk platter is referred to as a physical block. The physical block number BPN is an address used for identifying a particular block on the surface of the disk. 5. Logical block. When the blocks on the disk are considered from a programming point of view, they are viewed as logical blocks. The address of a logical block on a disk is its logical block number, LBN. LBN 0 is the first LBN on a disk. Logical blocks correspond one for one to physical blocks, but the logical block number might not correspond directly to the same physical block numbers. In some systems, the disk controllers and some disk electronics are capable of detecting a physical block that is defective for storage of data and places it with a spare block from the same disk. When this occurs, the logical block number does not change even though the physical block number is now different. 6. Clusters. With large disk capacities, it is inefficient for the computer system to deal with millions of individual blocks one at a time. Accordingly, disk blocks are grouped into clusters, which are groups of blocks read and written as a unit. In other words, a cluster is the minimum allocation quantity for a disk. The cluster size in terms of number of blocks per cluster can be varied by reinitializing the disk. 7. Files. A file is a collection of data that has a name and is stored in a computer. It could also be described as a collection of physical records organized for efficient access. As far as a computer is concerned, the operating system knows the beginning and end of any file stored on a disk. Files are treated in the next study section. Summary. In study section 4, you have learned that 1. The logical view of data is the way data are perceived by end user or business specialists. This means how data is seen from the user's point of view. 2. Every information or data used by the computer is stored with binary symbols. By binary we mean having two and only two possible states, such as on or off, true or false, and 0 or 1. 3. Every information or data used by the computer is stored with binary symbols. By binary we mean having two and only two possible states, such as on or off, true or false, and 0 or 1. 4. When 8 bits are considered together, they are referred to as a byte. A single 8-bit byte is the amount of computer storage typically used to store a single letter of the alphabet or other symbol of human communication. 5. The surface of a disk is divided into sections. This sectioning is not a physical marking on the surface, but rather it is just an idea that the disk is so divided. 6. With larger disk capacities, it is inefficient for the computer system to deal with millions of individual blocks one at a time. Accordingly, disk blocks are grouped into clusters, which are groups of blocks read and written as a unit. This is the end of study section 4. Thanks for listening.